Hello, this is Physics 1 Lab 1, Constant Velocity, by Henry Dowling. To start off this lab, the purpose of this lab is to observe the motion of some object that is moving at the same speed without changing direction. This was done by recording the motion of an object moving at a constant velocity and then simulating that motion using Glowscript. The main physics equation to understand this lab are F-net and change in position. Since the object is moving at a constant velocity, all forces cancel out, and the resultant net force is zero. Therefore, we use the simple update change in position equation, which excludes F-net. It's also important to note that for this lab, the system was a tape roll moving across a table, which acted as the surroundings. I recorded a roll of tape spinning across a table. I then exported my video to Tracker, rotating the axis so that the tape rolled in the positive x direction. I was then able to get an observed position versus time graph and the relevant data from the tracker and exported it to an Excel file. With the tape roll analysis complete, I used the data I collected to create a model in Glowscript. I started by editing initial position, initial velocity, and delta t using my data. For delta t, I used the time step given in Tracker, 0.033. Since my initial x and y positions were extremely close to 0, I assumed my x, y, and z components of position were 0. For initial velocity, I used the change in position formulas, with the F-net section cut out since I assumed F-net was 0, as is the case given the velocity should be constant. Since my y position didn't change, there was no y component of velocity. For the x component of velocity, I used the final position in the data for x final, as well as the overall time for a change in time. Since I didn't have data for the tape's mass, I kept the mass at 1 kilogram. In this case, the mass is irrelevant to the data. It would only be important if the net force was not 0, because then there would be an acceleration. Continuing in Glowscript, since I assumed the net force was 0, I reset the F-net vector and kept the update velocity formula the same, as there would be no change in velocity. For the update position formula, I simply plugged in my calculated initial velocity and change in time to get a more accurate change in the position vector. I then ran my script and got back the calculated position versus time graph and velocity versus time graph, which of course was a flat line, indicating velocity didn't change. I exported the data from this model to Excel and compared the observed change in position to change in position predicted by Glowscript. Since the y position is constant in my data, I decided to focus in on just the change in x position. The result showed that the observed position of my object very much resembles the position of change of an object with a constant velocity, although there are a few deviations here and there. Looking back over these graphs, I realized my data could have been much different if I hadn't rotated the axis of my object's motion. Technically, in the video, the object was rolling in the negative x direction, which would have resulted in a change in position graph with a negative slope. However, either way, the velocity would have been constant. Since for the purpose of this lab, I assumed the net force was 0, this means all the forces acting on the tape had to be balanced. I knew the force due to gravity and the normal force balanced each other since the tape didn't roll into the table. And because the force I used to push the tape had already been removed, I knew there were no forces acting along the axis of motion, assuming friction and air resistance are negligible. This is a fair assumption, considering the tape and the table both had smooth surfaces. Therefore, it makes sense that my object's motion closely resembles that of constant velocity, as the overall net force is 0.